Our session today is Convergence of Network Security and Compute at the Edge. And myself, I'm Sadaf Jalal, VMware Security Solution Architect, and cover the Edge business unit for SASE, SD-WAN, ECS.
Hi, everybody. Good afternoon. Kieran Roach. I'm a co-founder and CTO of CoEvolve, and we're a specialist global managed service provider. Spent a lot of time deploying the VMware SD-WAN and SASE product, and looking forward to the discussion today. Thank you.
Thank you for being here.
Thank you.
Good afternoon, everyone. Andy Forstner. I am the Director of Product Management for AT&T in support of our Edge portfolio, which would be all of the different SD-WAN offers that we support in the market, as well as our portfolio of x86 platforms where we support different virtual network functions.
Hey everybody, so I'm Saqib Akhtar, so I'm a solution architect covering SASE, SD-WAN, and Edge Compute globally for VMware.
So let's get started. We have an interesting panel topic here to discuss today, and we're basically talking about the changing evolution that we've been seeing. In March of 2021, I believe, a lot of us were on travel, and we got a call that you need to head back home and COVID is hitting, and everybody needs to be isolated in their rooms and work from there. And that's when enterprises were faced with the challenge of dealing with distributed environments, like having any type of workers, whether they are contractors or partners or interns, work from anywhere, home, Starbucks, or basement, and have the ability to access applications anywhere, right? Whether they are in their data center or there are SaaS applications. And that's when enterprises were challenged with going into this distributed model of providing security and performance and connectivity, and at the same time making sure work isn't compromised, speed isn't compromised. And now as that trauma has gone down, we see that the workforce is returning back to the branches. What does that mean? It means, do we need the edge to be transformed? Do we need some of that network connectivity, performance, security, and compute power to come back at the edges? So I think my first question is, what transformations are we seeing at the edge? And Kieran, do you want to start that off for us?
Yeah, sure, absolutely. So I think as you said, it's an interesting time, both in terms of what's happening overall, given the changing work patterns, but we see it probably most of all in some specific industry verticals. So we work a lot with manufacturing businesses and engineering, construction businesses that are very data-centric. And we're seeing a few really big trends that are happening at the edge. One is definitely the need to do more at the edge, so new workloads, either IT-related or line of business-related, and I think we'll get into that with some of the topics today. But we're also seeing this convergence of network and security becoming not just a network conversation with security bolted on, but very much a combined conversation about the two. And part of that is being driven by just the changing threat landscape and the need to be just much more aware of security overall, but also I think the market has moved on in terms of new offerings and capabilities becoming available, and that's put a whole new level of focus on what you put at the edge, at the branch, at the factory, at the retail store, and what type of both security, but also what workloads are being deployed out to those environments. So definitely it's changing quite significantly from what we've seen in the past couple of years.
Oh, that's great. And Andy, what's your take on it?
Obviously, the return to office thing is happening with a lot of different organizations, but I think that there's still probably a work from home component that's going to linger for quite some time. I think the edge and security are just network and security components. I think that there's, obviously with SASE coming into play, I think that there's probably a lot of discussions that organizations are having about what that really means to them, how they support kind of the five primary pillars of SASE, and whether or not those are going to be vertically integrated from a single provider or those are going to be from best of breed. And the use cases that are kind of driving a lot of the development and new capabilities at the edge are coming from customers who are building out use cases to solve for problems, knowing that they have new tools available to them that they didn't historically have. Edge compute is certainly one of those, and I think that their adherence to trying to make sure that they provide a unique and differentiated solution that optimizes the performance of that application helps kind of define where that application is going to live. So either that's going to be, we're going to talk about far cloud and near cloud, but where that application is going to live, what the latency characteristics are associated with that application, and what it can support. But I think that as we progress, network and security are going to continue to integrate more. Customers are going to define what that means to them, whether or not they need full stack security at the end, if they can push that into a near cloud type of solution, such as a CWS or a SWIG type of solution. But it's going to continue to evolve, and customers are going to take advantage of the new capabilities that they have available to them. And obviously, we all want to be in a position to help provide the foundation for them to do that.
Okay, that sounds great. And Saqib, so we are hearing about these edge-native applications.
Right.
And then we are hearing about these cloud-native applications. So what does that mean? Like, what kind of use cases are we thinking of, and what are the challenges?
Yeah, no, definitely. So if you think back to edge-native applications, it's really about what are the challenges that these applications are actually facing at the edge as well, right? So like Andy was saying, some of them are latency sensitive, some of them might be data centric as well, or data sensitive, meaning they need to process that data, or the data is too heavy to actually send back to the cloud as well, right? So it's, I think you were talking about people working from home and stuff, but there's also other aspects of the edge as well, where I don't know if anybody went to the keynote that Sanjay did, which was Everything Everywhere All at Once, right? That was the title of it. And it's really about, you have these, not millions, but billions and trillions of sensors out in the world today that are all generating traffic and all needing to do something, right? As an example, I was talking today to somebody, and there's a convenience store in the US, and they have cameras. And if that camera doesn't work, the store closes. That's how critical just having a camera feed working and live needs to be. And the issue is that camera actually sends data back centrally today, but why not just have it locally, have a local feedback loop there? Just as one example, of that.
That's a great example. And just coming from having a little bit of a background in the aviation industry, they also use computer vision for doing passenger count in the TSA lines. So based on computer vision and determining the wait times for each lines, that allows them to determine if more lines need to be opened.
So just a quick note on aviation. So I recently just relocated to Dubai. You guys I was telling you guys. So over there at the airport, they have what's called as paperless check-in. You don't need your passport. You don't need your boarding card to get from the outside of the airport to all the way inside. They don't check anything. You walk inside. There's a little kiosk which has edge compute inside of it. Right. It looks at your face. They know everything about you there. Privacy is not an issue. It's not there. But they look at your face, they scan it, they know who you are, and they already know that you have a valid flight ticket, and they basically check you in. And the next step is pretty crazy, is what they're doing with edge compute at different locations.
So I think to summarize it all, then, it's fair to say that the transformation at the edge is because we have all these connected IoT devices that are generating massive amount of data, number one. And number two, decisions are being made at the edge, right? So like you said, nobody's getting scanned, but some kind of checking, processing is happening at some stage. For example, at the TSA line, lines are not just opening up automatically. Wait times are determining. There are edge-native applications that are allowing them, giving them the power to determine, how these decisions have to be made at the edge without sending this data to the cloud. So now that brings us to the next, we understand why this transformation at the edge. So the next topic then that we do want to cover is, how do we create that balance, right? What is the balancing act between the edge and the cloud? And before we go any deeper into that, I'd like to ask some of the audience, we use the term near edge and far edge. So how many of you think near edge is the branch, or the factory, or the retail store itself? Or how many of you think it's the cloud? Raise your hand if you think near edge is the cloud. And raise your hand if you think it's a branch. Okay, and some of you just didn't raise your hand, so.
Well, I guess on the flip side, what would you do? What about the far edge? If the near edge is the branch, then what's the far edge? Right?
It's a good question. So, from a data center's perspective, the far edge is the branch. Would you agree with that, Kiran?
Yeah, definitely. And that's historically been a very simplistic environment. All the intelligence was traditionally in the data center. It's where you put the applications, the infrastructure, and it's now we're seeing the need for these applications, as we said, to be deployed much further away from the data center, closer to where the source of the data is, at the branch or the factory or whatever it might be, and for the workloads to be able to run there as well. So
Yeah.
definitely.
Yep. And then I guess that would say the near edge is the cloud then.
The near edge is the cloud.
So before, like 10 minutes ago, I was using ChatGPT. I asked ChatGPT the same question, and it gave the reverse answer. So don't trust ChatGPT. So that's what I came back with. I think it actually it depends on what the center of the universe is, right? When you ask that question, in ChatGPT's mind, the center of the universe was the data source, right? So they were saying that the near edge, if you're closer to the branch, that's where the data source is. That's near to the data, so that's the near edge. And then, of course, the far edge is if the data is far from the from there, that's the far edge. Right. But most people, I think, don't agree with that terminology. And the far edge is the branch, and the near edge is the cloud, or like a SASE POP, or example telco.
And I would say, from a telco perspective, running data centers and POPs, the near edge would be the cloud and the far edge would be closer to the data source. So just wanted to make sure that before we go any further into this session, that definition is cleared up in everyone's mind.
That's a good question. It is ambiguous.
Can you repeat the question, Saqib?
So when I looked at it, it's primarily from the cloud service providers that came up with that definition, in the sense that the near edge is their cloud, right? Because it's close, it's their perspective of being closer to it, and the far edge is far away from them, which is the branch and further away. Like I said, ChatGPT has the reverse interpretation of that.
So Andy, I'll have you kick this one off. How do we then create a balance of what we do in the cloud from a security standpoint, connectivity standpoint, performance standpoint, compute, and what do we bring closer to the users and the devices and the decision-making point?
Yeah, I mean, use cases and success criteria are usually the two things that are kind of the foundation for that. So, from a networking perspective, you're usually going to be looking at what is the latency profile or performance profile of the applications that I have. So where can I put it to get the right low latency to be able to support near real-time transactions? What use case applications can I put on that far edge to be able to support that low latency requirement, and whether or not it can reside there or it can move further out into the near edge. So the networking aspect of that is obviously a hugely important aspect of that. And then as you kind of take the step up to the security aspect, every vertical is different, every use case is different. Some customers, the majority of customers, are kind of embracing that SASE framework. So whether that's like an SD-WAN or secure service edge architecture, or that's a vertically integrated full SASE stack from a single provider. So as folks kind of determine which is right for them, they also need to make a determination of how much security is right at the edge. If I have to do east-west firewalling and protect for PCI compliance, and all of a sudden my criteria is going to be a little bit different as to what technology is going to best serve to resolve those use cases and provide that success criteria. But it varies by vertical, it varies by business, and our goal, I think, is from y'all's side to develop the technology that enables customers, no matter what their use case might be. And then Kieran and I are obviously trying to take the great technology you guys have and put that into a way that customers can digest it in a flexible and meaningful way for them. So there's no one size fits all for any of it.
That makes perfect sense. And Kieran, do you want to add on to that, as in what we are retaining within the cloud and why those changes?
Sure, yeah, I think a really good example, and we see this a lot with clients, we do a lot of work with manufacturers that are starting to look at how they can combine their OT, their operational technology, and their IT environments. And I think that's a perfect example of where we have to work with the client to help understand what needs to be at the edge. And it's similar to what we just mentioned with talking about compliance and regulatory requirements to keep certain traffic controlled at the far edge, at the branch office itself. But the IT users at the site can use cloud-based security solutions and so on. So anything that needs to be done at large scale, very high intensive compute power that isn't particularly data sensitive, generally that's going to be a better fit to be done in the cloud. So not necessarily all the way back in the very center of the cloud where it's one instance being used for everybody, but distributed within that cloud environment, so that if it's a secure web gateway, for example, that's something that can naturally reside in the cloud. It can provide a consistent policy. It can filter internet traffic for all of the users. You don't need to do that all the way back out to the branch office, because these are going to be situated in points that are quite close to where the internet is anyway, and you're not going to degrade their performance by sending the traffic through there. So that's, even for a single site with a common set of users, we do find that there are certain applications that are best controlled and managed locally, and then some that can quite easily be sent and are probably better to be sent further into the cloud. So definitely anything that's being done at that large scale, we typically see clients retaining in the cloud, either in a centralized or distributed model in there.
Yeah, just to add on to that, I think what Karen is saying is that if the workload requires elasticity, or if it needs to scale out, it definitely makes a lot more sense to run that in the cloud, obviously. At the edge, if you have 1,000 sites or 100 sites or even 10, 50 sites, what you have there in terms of compute resources and even networking and security resources is relatively static. You're not going to do continuous truck rolls to get new equipment out there, a new server out there. Whereas in the cloud, it's relatively infinite. You can keep scaling out as you need. And I think both Andy and Karen said that edge compute is very vertical centric, in the sense that, as a show of hands, I guess, how many of you guys are in the manufacturing space? Show of hands. Okay, we have a couple there. What about like retail? So it's quite a bit there. We see manufacturing, retail, healthcare. All of these are, we see a lot of edge compute use cases out there for these. As an example, we were at the booth. I don't know if you guys saw the big Lego table at the expo there, but we had about, I would say 10, 20 different manufacturing customers that came there, and all of them took a picture of it and said, "I'm going to send it to my OT guy." So there's that, like you're saying, there's definitely that convergence of IT and OT coming together. They didn't invite them out here, it looks like, but they're getting pictures sent of what innovation is actually happening on the edge compute side as well.
And if you've been on the floor, you see that huge truck from the Sussex Police, and that's a great example as well, right?
Yeah.
They're showing how within one ruggedized device, they have the foundational underlay, like the 5G LTE built in, and on top of that, they are now putting in compute, which is allowing them to run the edge native application, to run any of the workloads that are needed by the police to catch any stolen cars or detect any passengers and their background checks. So that's the type of use case that we also saw from many different cities coming up and asking, what is this use case? Maybe we can try it out. So I think that's a great example as well.
Yeah.
Okay, we're having some, clicker issues here.
It's going to be an eye contact.
And now we're having some eye issues.
Eye test here.
With edge native workload, what is the impact on the network security and compute? And Saqib, do you want to kick that one off for us?
Yeah. So I think, I use this phrase, everything everywhere all at once, in the context of endpoints and sensors, but it's also the same for networking, security, and compute. You're having that all converge at the edge as well, just like at the data center, right, where you need all three of those components. Like if you look at a manufacturing example, like PLCs, very highly sensitive to latency, highly sensitive to CPU cycle time as well, but also highly sensitive to security risks as well, right? If you somehow get access to the PLCs, and typically that traffic is not encrypted in any way. It's usually layer 2 traffic and very simplistic. But the need for having that security, even on that east-west traffic in that scenario, becomes really important. And the same goes for healthcare as well. That was a manufacturing example, but you don't want your glucose monitor or your whatever healthcare equipment that you have to be compromised by any sort of malware or ransomware type of attacks as well.
Yeah, and from an AT&T perspective, going back probably around 7 years now, I guess, we've developed a platform we call FlexWare, which we've evolved, which has an ecosystem of virtual network functions that are, we have some virtual routers on there. We have multiple different SD-WAN flavors. Obviously, a great partnership with VMware in regards to that. There's other security capabilities, visibility capabilities, and that's one of the things that The flexibility needed to be able to support multiple diverse verticals and use cases is kind of what drove us to that platform. And it's impressive to see the different ways that customers pull from those different options of capabilities to work with our technical teams to service chain those capabilities in an effective and meaningful way so that they can protect against all those different use cases that you have. And that, I anticipate, will continue to evolve. I think there's always been this goal of trying to do edge compute. We started 7 years ago. We've tried to see different ways that we could put some type of a container or a way for customers to deploy a unique use case. We still work with a lot of customers to try and drive different solutions to support some of those. And it's a unique time where customers are trying to get more creative about the way that they are driving their business forward. And they're realizing that the competitive differentiators that worked in the past might not be the ones that provide them the differentiation in the future. So it's great to have people that are thinking outside the box, thinking about what type of performance they need out of their applications, which drives them to where that application should be supported. And then that helps build this whole ecosystem of edge compute capabilities that I think we're all trying to advance.
So I'm going to add one more thing there. So we announced the Veko platform, which is the VMware Edge Cloud Orchestrator, which is really network security and compute all in one kind of platform to orchestrate to the edge, right? So when we talk to customers like Home Depot and others as well, which have large retail footprints, one of the challenges is how do you actually roll out compute to all of these different stores, these branches, these factories, these whatever it might be, at scale, and it's typically 99.9% the same config for all three of those components. But how do you do it at scale, right? And that's really what we're trying to solve with Veko as well, is have that platform that can do those three functions at the edge at scale.
Yeah, orchestration, control, and instantiation are tough problems to fix. So thanks for getting on that.
Yeah. And I think one of the challenges we've seen clients face is as soon as you open up the possibility of compute at the edge, there's so many more stakeholders involved. So the imagination of the IT guys might extend out to say, well, we'll run a DNS or DHCP server, something IT related on that compute. But if you open it up to the line of business, then they can have just wildly different requirements. So if it's a retail store and they're using computer vision to track attendance at the store, then maybe that needs to have GPU capability. It might need more storage depending on other use cases. So depending on what they're intending to do with it, you can have lots of brand new requirements coming into that there. So it adds to the complexity in terms of sizing and scoping what you deploy at the edge, but the benefits are there if you can get past that and have a structured way of managing those expectations, deciding what's realistic and what's not, and then building a plan to deploy those workloads using some of these new capabilities as well.
Yeah, and I think that's where VMware is adding value. Saqib, you mentioned VMware Edge Cloud Orchestrator, Veko, has that ability where we are now unifying the SD-WAN Foundation network. Then we have all of the security, so all of the SASE configuration capability of monitoring, management built in. And at the same time, we are now bringing in the ability to also scale out compute from there. And scale up and scale out is really key, right? Like if you can take that use case, for example, the Sussex Police, that could be applicable within many different cities. If we can take the use case of manufacturing, that could be applicable within many different manufacturing, retail, and the same idea applies. So scaling up and scaling out is one of the key requirements, I guess, for upper level management to get a realization of.
Yes.
And maybe that's key. And from our end, if we talk about the edge, VMware, within their SD-WAN devices, we've also now built in enhanced firewall services. So that's from an edge perspective, if we are bringing in an SD-WAN device, we are also converging security within that same device. So within a single box, we are providing that capability. And now we add compute. VMware knows how to do VM and container. So if we add that ability within that same ruggedized device, we really scaled that for the customer. And now, even from a management perspective, that's being done. And on the POPs, what kind of enhancements are we doing? Who wants to take
Good question
that?
for Randy.
Everybody expects the AT&T guy to take one about the POPs.
AT&T guys going to take that
AT&T
one.
is doing.
Yeah, I knew that one was coming. Like a lot of different businesses, we're trying to optimize the services that we provide to make sure we're delivering the most value to our customers. Our POPs support multiple different services, right? We've got obviously, the nation's largest wireless network. We have a huge MPLS core that we operate. We have, leading, fiber at the edge in our 21-state footprint. What we're really trying to do is make sure that we have the flexible service offerings for any customer, no matter where they are. And, the POPs are interesting. I think years ago, AT&T had hundreds and hundreds of POPs. There probably aren't as many POPs these days. We're consolidating those services down. You don't need as many now as you did then. But we're also looking to bring additional services into POP locations, right? So we kind of have a unique relationship with VMware. We actually have our MPLS core that we have brought into VMware SASE POPs that allow us to not only provide the great SD-WAN service that VMware provides to overcome the packet loss latency and jitter that is associated with the edge of the network, but once we hit our SASE POPs, we can actually use that MPLS core to provide a mid-mile optimized connectivity option for customers. So you can your connectivity can come into those POP locations. We can take advantage of VMware SASE in those locations. You can utilize the MPLS core to be able to overcome traditional network challenges associated with peering arrangements or just general inefficiency that takes place within the network. So the POP continues to evolve. I think they also continue to consolidate. I think of where a lot of people's, the legacy POPs are probably the next generation data centers. A lot of them are Equinix and CoreSite facilities, things of that nature, where we all kind of meet together and then customers kind of select the services they want. Oftentimes, obviously, VMware service, but you guys obviously work very well with either the cloud compute capabilities or some of the other cloud security capabilities that are out there. So the POPs of the future are basically the meet-me rooms with all the additional services that customers need to be able to support their business as it evolves.
And Kieran?
Yeah, we have no POPs, so I can't add a whole lot to that, but no, it aligns well with what we're seeing. And I think this idea of the POPs sort of naturally converging to that point where there's a lot of other connectivity to other destinations, whether it's cloud applications or other type of infrastructure capabilities, that's very much aligned with what we see enterprises looking for, that they want to be able to be directly connected to those types of environments, because we're really seeing that the public cloud is becoming that new center of gravity for the enterprise network in the way that the on-prem data center used to be. So we're seeing enterprises really focus on how they get to that public cloud very efficiently. So I think that's changing the topologies of the networks that are used to get there.
Okay, so I think we should take some questions. Any questions here from the audience? No.
It's always tough.
This one in the back.
In the
Yeah,
afternoon.
go ahead. Just yell. So I'll repeat the questions, but I'll also ask a clarifying question as well. So the question is, in terms of the edge appliance, so I guess, can you define what you mean by edge appliance first, I guess?
No, so you said something about moving everything to edge, like all the containers and all.
Sure. Yeah.
But for that, you need an appliance or something.
Got it.
So what are the economics of that appliance? People might like them, but is the market fully ready for
Yeah.
a device and
So yeah, so the question is that, hey, you're moving workloads to the edge. Is there cost benefits of doing that? Is there
a market
is there a
economically?
market? Yeah. So I think I'll take it, and you guys can add on as well, of course. So I think definitely not moving all workloads to the edge. I think the workloads that are moving are either net new workloads in the sense they're new virtualization use cases or new consolidation use cases as well. As an example, like I'll go back to the manufacturing one, is that PLCs, there's 1 billion PLCs in the world today, right? And all of them today are physical form factor. And you can actually save money by virtualizing that, right? You're taking hundreds of PLCs in a single factory floor and putting it onto a compute cluster and taking other workloads that are also in the factory and consolidating it onto that same compute cluster as well. So in that scenario, it's a win-win in terms of not only are you saving probably power costs and you're doing better sustainability, but you're also probably saving money on operational costs as well, right? Because now you don't have to manage that physical appliance anymore. You can use it. You can manage it as just a VM, right?
I mean, it's a great question because I think about it all the time. You know, to a certain extent, I think it's a build it and they will come sort of things. I think you build the capability and then people start to take advantage of that technology. I think 5G is a similar thing, to be honest with you. You can get great throughput associated with LTE, but 5G is there to be able to provide the foundation to build unique use cases upon it, right? I look at edge compute similar in that fashion. I mean, from an MSP perspective, again, we've had some customers who have these unique use cases. We've already talked a little bit about facial recognition. We've worked with some folks on drone fleet management. You know, we've got people that come up with these creative use cases, and that, you know, takes me back to like that whole how much latency is acceptable to be able to support that specific use case. And so, you know, from an MSP type perspective, you know, we look at that. Is it here? Is there a way, quite honestly, to monetize it? Is there a way for us to provide the flexible management of a container of edge compute to a customer such that they can use it, but yet me as an MSP is providing some level of value that is worth charging? And so we still work through those things, but again, I think you're at the very beginning of what will be a rapidly growing market over the course of the next few years. So
and I think it's worth pointing out that the reason this conversation even exists is that the change that's happened over the last 10 years in enterprise networking to be able to move towards using x86 hardware to run, you know, networking hardware, networking appliances that can operate at high levels of throughput. That was really an enabler for a lot of what we're talking about here, to be able to have hardware that wasn't dependent on custom ASICs, that now can be part of a more general compute platform that you can now start looking at other workloads on top of it. So we've seen that be a really big change, that in the past, it's not new necessarily to deploy like a VM host out to a branch. What is new is that the network and security piece is part of that same conversation.
Absolutely.
So it's the convergence of it has been really enabled by that change that it just didn't exist even 5 years ago. It wasn't very common. So I think that's a big driver for a lot of these types of transformations we're seeing as well.
You know, in terms of monetization, so in Dubai, all the red light cameras, there's $10,000 to break the red light. Right. And you know, you get an SMS right away to make your day go great after that. So it's
So they've covered their second key takeaway: predict demand and match investment.
There you go.
So they're putting that application on the edge. They're making sure they're getting their money back.
yeah.
And again, to your point, not all applications are moving to the cloud. That's why investments are being made in the POPs, right? The SASE exists. There's a big market for it. A lot of the traffic going between the user and the SaaS application is being secured within the cloud, right? All of the CASB, DLP functionalities, all of that zero trust, remote access capability, that SSL decryption is happening within the POP still for applications that don't need to be at the edge, right? And natively are cloud native applications as opposed to edge native applications, or in the past we had the client server architecture. We're not that anymore.
right.
And I guess any more questions before we close?
Yeah, go ahead.
Yes.
My question is, how does mobile play into this whole edge definition?
I can speak to that from a project we're doing with a client at the moment. I think it exists in two ways. One, mobile as an underlay component of the edge, so being able to use 5G, being able to use low Earth orbit satellite and so on as a way of getting from the branch into the network. That's one piece of it. But we're also seeing, and we see it in manufacturing, we see it in, we've got a large global client that's involved in commercial property management. So they've got a lot of focus on smart buildings and collecting data from sensors in the buildings. We're seeing a big increase in focus on private mobile networks and private 5G, for example, which obviously has a dependence on a RAN, a radio network on the campus or on the site itself, but there's also a lot of compute power needed to support that as well. You need to run the various components of the applications that control that environment. And some of those you can deploy in the cloud, in the SASE POPs, for example, but there's components of that that are latency sensitive that need to reside locally, so then they become workloads that can be deployed out at the site as well. So we're seeing clients deploy this alongside Wi-Fi at their either factory floors or warehouses or high-rise buildings as a way of having that predictable capacity inside the building for latency-sensitive workloads or just high-resiliency workloads that they need to make sure the traffic can get from the sensor or the endpoint back into the network itself. But it's definitely dependent on a level of compute there at the edge to make that work as well.
And actually at the booth, one of our colleagues was telling us that a company came around and they carry money between banks. So they have a lot of applications and a lot of different devices to secure the money, manage the money, count the money, and their truck is loaded with a lot of different devices and a lot of different applications for that reason. So providing that one ruggedized device that has the capability to carry your LTE, your network, your security, and provide all of that feature to run out of that box and give the decision-making power within nanoseconds, I think that's going to be one other use case.
Yeah. Just to add to the 5G piece, obviously private mobile, 100% agree with you on the use cases. And I think, again, just you're going to see this evolution of 5G continue to take place over the course of the next couple of years. I mean, you've got some challenges right now just with the cost of what the radios take to put in certain devices. It's obviously pretty cheap to put LTE, and LTE gives you pretty darn good, reliable, high performance throughput right now. But as you start getting into 5G and really taking advantage of the network slicing capabilities to create fast lanes for certain traffic with different prioritization, that's going to add to the ability to deliver some of these creative use cases around the edge of the network.
Any other questions? Well, thank you everyone for attending, and thank you, Karan, thank you, Andy, and thank you, Saqib. It was great having all of you here.
Great. Thank you.
Thank you very much.
Thank you.